Boom. Okay, we're recording. Nice. No worries. Thank you. Always aim to do it and then just forget. Where was I? Oh, okay, here. Completely forgotten. Oh, there we are. Okay, so we're going to go demonstrate what we need to do. So we're going to try and demonstrate how classes talk to each other. This extends the work that we've been doing in the past couple of weeks of trying to think about how we design programs or we work with multiple classes. So let me get rid of this. So we're going to try and describe a very simple example of like a few classes working together. And this is almost the set of requirements that we're going to try and diagram and then write code for. So I'm going to use this to write code. I'm going to see whether this can work neatly. And if I'm showing my screen, I'll have to make sure I flip appropriately between them. So let's take the first part here. The CEO executes a method, make company efficient. So I imagine that we have an object called CEO and a method called make company efficient. So that's the first part I'm going to try and diagram. So if you look on the mirror board, either on my screen or if you have it up yourself, it's probably better if you just look at my screen so you don't have to flip screens yourself. So let's say we have an object. I usually draw objects as a little box, and this is going to be our CEO object. And the requirements say that it has a method make company efficient. So we're going to have here make company efficient. And the next part that says this delegates to another object's method, and this is called the COO. I guess that stands for what? Chief Operating Officer. Has a method called find company savings. So inside this method, make company efficient, I want to ask another object. So I'm going to essentially send a message to another object, which is going to be my COO. And I want it to do some work. So the work I want it to do is find company savings. So I have a CEO object that has a method make company efficient. When I call it, it will then ask the CEO to do something called find company savings. Okay, so then we have the same pattern again. This method does a couple things like sell old equipment and reduce entertainment budget. Okay, so this method has a couple of things.
Very sad example. This is making me unhappy.
I'm sorry. Sell old equipment. Yeah, get rid of that fax machine. And reduce the entertainment budget. Okay, so these are things that it does. Entertainment budget.
Can you show us the mirror screen again, please?
Sorry. Let me put that over.
The CEO has his hands full.
CEO is at the golf club.
Let's see if I can do a little bit like that. Okay, so we have a CEO that says make company efficient, and then we go to a CEO who says find company savings, which does a few things. But it also does another thing, which says it calls HR manager's method reduce payroll. So we have an HR manager object. which then says reduce payroll. This method iterates through employees and calls employee fire if employee performance is less than 7. Hopefully that's at 7 out of 100 or something, we'll see. So let's try and diagram that. So we have an HR manager reduce payroll, which let me make this a little bit bigger so I can keep doing some work. Calls employee fire. Oh, can't get that way. So this has essentially probably like a set of employees, right? And then it will ask the employee, let's put the employee, what's the name of it? Employee. And each one has its own method called fire. Essentially, an employee will fire itself. How fun. We'll talk about why we'll do that later. So HR methods reduce payroll, iterates through employees. So we'll probably have a few of these. Employee. They all have their own fire method. We iterate through a list and we call it if the employee performance is less than 7. So an employee has a fire method and also has like a performance method. In this example, neither the CEO nor the COO are responsible for firing employees, and both have plausible deniability. That responsibility has been delegated to the HR manager, who will have to handle the angry letters themselves. How fun. Okay, so before I go and like use my diagram to write some code, let's just have a quick pay attention to the way that we diagrammed this. And this is trying to get you to sort of see objects like passing messages along. The CEO doesn't directly send a message to the HR manager. CEO actually has no idea that the HR manager exists. The CEO only knows about its most immediate neighbor, the COO. And this is an important idea to keep in mind, that we don't reach in, we don't reach across a chain of objects. Each object only knows about its immediate neighbors. And that's all it should do. So the CEO will just run this method, make company efficient. It will ask the COO to. So at some point, we have to inject the COO into the CEO. And when we think about that, literally, yeah, let's just talk about it figuratively. These objects. So we'll have a look at how we actually write code in a second. But again, the important thing here is that the CEO only knows that the COO exists. It doesn't know the HR manager exists. I wish that were the case in reality. So on and so forth down the chain. Now, this idea of passing messages across is called, we're delegating to other objects to do work for us. Sometimes you hear this called method forwarding. We forward messages to various dependencies to do that bit of work. So at the moment, we'll be using the ideas of method forwarding and delegation quite similarly. There are some distinct differences, but at the moment, let's just not worry about it. So yeah, any thoughts or questions before we start writing code to represent this diagram?
It will be a question for after we've started writing code, but I'm interested in how this ties into mocking.
Yeah, cool. As you go, have a think about how to specify your question. Okay, so let's have a look at where we go. So I'm going to start off like trying to imagine what I want these things to do, and I know that I'm going to, so I'm going to try and split it into two sections. This is going to be like at runtime. This is what I want it to happen. And this up here will be right, source code. So let's go over here so we can see. So at runtime, I want to be able to create a CEO. And I'm going to inject into it a chief operating officer. And my chief operating officer is going to be an instance of the chief operating officer class, who will have an HR manager. My HR manager is going to be an instance of the HR manager class. HR manager, like that maybe. And the HR manager needs to have a set of employees. So let's initialize our HR manager with a set of employees. Where our employees be a list of employee.new. And let's create employees with like a performance out of 10, shall we? So our first employee is going to be a superstar with a performance of 9 out of 10. And our second employee is going to be an employee who's not a superstar. Let's just say like he's a 5. And then let's create an average one of 7. Average is 7? Well, there we are. I've got high standards. Okay, so let's just imagine this is the scenario. I'm using like an argument to my initialize method for employee that will have like something about their performance. So this is what I imagine is going to what I want to happen, and then we need to kick it all off by saying CEO.make company efficient.
Warning. Method will make permanent changes.
I'm glad someone picked up on that. So this is up here. So this is what kicks it off. And notice at runtime, this is all essentially set up to have things happen. But a CEO doesn't only, the only thing CEO knows about is the chief operating officer. They talk together. They're like the senior management team. And everything else cascades from there. We forward all the messages down the chain. So up here, the CEO takes in a chief operating officer, and that's how we're going to do it. So let's have a look at just creating these classes so you can see how this works. So let's create our CEO class. And we need to inject a chief operating officer. So let's create our initialize method. And it takes in chief operating officer. Let's default it to a chief operating officer, an instance of that. And let's store it. Coup. And we need the method def make company efficient. What does this do? According to our diagram, it's going to ask the CEO to find company savings. So we ask the CEO to find company savings. So this way of writing it is essentially the essence of trying to build this picture in your head of like how the objects are sending messages across the chain. So I inject the dependency through the initialize method, and then I store it in an instance variable, so I have access to it. And then I send it messages as I need to. The CEO class has no idea how the COO is going to find company savings. It doesn't care about that. It's telling CEO, do your own work, you figure out what to do. And the CEO will do its work. And this is important. The idea of having sort of objects is that we're not reaching in to other objects and messing with their internals. We're just saying, I'm going to ask you, send you a message, and you take care of the rest. You figure out what your state is and what you need to do. I'm just going to send you a message. Cool. So then let's make our CEO class. So then we make a class called the Chief Operating Officer, and we need to initialize this class with an HR manager. HR manager, and let's instantiate it with an instance of an HR manager. We need to do the same thing. We need to store it in the object. So we're injecting our HR manager into the Chief Operating Officer, and we store it. And we ask it to, we need to find it, define the method find company savings according to our diagram. Find company savings. And here it says, it does a few things. It says sell old equipment. We'll figure out what this is in a second. Reduce entertainment budget. Entertainment budget. And then we ask the HR manager to reduce payroll. The same pattern. We ask our HR manager to reduce payroll. We forward the message payroll for reduce payroll to our HR manager. So what are these two methods? I guess let's just make it, let's make them up. I guess let's initialize our Chief Operating Officer with a budget. Start off with a budget of £100 because this is a very fancy company. And I guess let's create a couple methods to do some work for us. Sell old equipment and reduce the entertainment budget. I guess this is a bit, we don't need to like define these, but let's just do it for completeness sake. And sell old equipment, we'll just increment this by a certain amount, plus equals. This doesn't really make any sense, but we don't need to worry about it. And then we'll reduce this one. It's not really making savings, but that's fine. Okay, so the important part here is let's go to our HR manager, reduce payrolls. Then we have to write our HR manager class. And HR manager has a method called reduce payroll. And what does this do? Well, it's going to take in a list of employees, which means we need to make sure we initialize our HR manager with a list of employees. Employees. And our reduced payroll is going to, what does it have to do? It's going to iterate through employees and fire if they're performance. So let's ask our employees, let's find all the ones who employee whose performance is less than 7. And let's ask each of them to be fired. Guess we use something like this. Calls and P5 and P5 system. So, let's make our employee class. Class employee def initialize with a performance. And we'll store the performance. And we need a fire. Okay. We'll just say fired. And we need a method performance. Okay, let's just make sure we can see it. Doesn't really matter at the end of the day. Okay. So that's how I would quickly sketch out this chain of objects working together, starting with an object, CEO, and each of the objects has another object that's been injected into it to do work for it. And sometimes you can have multiple objects injected into one. What I want to do is, let's just see whether it runs first of all. And then while I see it runs and maybe fix some typos that I've done, because I haven't sort of test driven this or even run it yet. So there's likely to be some errors. Have a think about what you've noticed and what questions you have, and then let's do some questions before we go and practice this. So where am I? I'm in this module. So what I want to do is just see whether it runs. Great. I guess there's only one employee who's less than 7, so that's why we only get 1 fired. If we make them all really bad employees, we get 3 fired. Great.
And
now
no
we have no
one
more.
in the company.
Now we have no one left, exactly. Okay, let's talk about some questions you have or thoughts about the way that I diagrammed it and the way that I wrote the classes to represent how we forward messages or how we delegate to other objects to do work for us. What do you notice, or what are your thoughts and questions? Let's start with Amit, because you're on my screen. Amit, then Amy, then Anastasis, then Sophia, then Ellen. Just any thoughts? So you don't have to if you don't have any thoughts.
Can this delegate way that we've done?
Yeah.
Can you pretty much apply it to any sort of, like, say, Oyster card or the airport example?
Yeah. Mm-hmm.
Can we use delegate there?
Yeah, absolutely, right. So I don't. Let's imagine you had like an Oyster card and a journey class. Maybe your touch in method, you want to delegate some bit of work in your touch in to the journey. So maybe the journey class should be responsible for knowing what is the entry station, what is the exit station. So the Oyster card shouldn't have to worry about it; it just delegates to the journey class.
Yeah, but should we? Sorry, but I guess the question is sort of like, should we aim to always delegate, right?
Yeah,
Okay.
and think about it from a responsibility point of view. What we're trying to avoid is one class that does all the work, and we're trying to figure out a way to have one class that does one thing responsibly, and then have other classes do their own responsibilities. We've got to figure out a way to make all these classes work together, right? So once we've figured out what the responsibilities of each class is, then we inject them so classes can sort of essentially delegate work to the appropriate bits.
Yeah.
So for me, the question is, sometimes I don't worry about it to begin with when I try and write a program. I want to just make sure I get all my like design or methods working first, and then I start to extract behavior and then forward messages to the classes to do work for it.
Okay.
So you should think of like little workers. So you can just get that thing to do a bit of work, design for it, and then get values back or return values back.
Yeah. And the other aspect was when you initialize an instance variable within your class. I always thought that should be like, so a good example is, say, the docking station. It makes sense for the docking station to have a rack of bikes. That's logical, but then it's not logical for the CEO to have within, well, the CEO to have within it a COO.
Yeah. Okay. Great. This is a nice idea. So I guess what you're talking about is like sometimes when we try and represent reality, it can feel a bit weird, where we have like a mismatch between maybe how like the real world would organize itself and then how like objects and code should talk to each other. There's not always a direct relationship, so we shouldn't always model reality exactly. So in this example, try not to worry about too much about like what the objects are called and just like how they're doing work and what work needs to be done.
Okay, so I guess it doesn't need to mirror reality actually that much. It's more about effective delegation.
Yeah. It's a really good starting point to model reality, but sometimes you'll find yourself moving away from it, where you're not modeling reality, you're modeling work that needs to be done.
Yeah.
And that's a really nice sort of like thing to think about over the next couple of weeks. What's that tension between starting with modern reality and what are the consequences of that? And then how do we model that work that needs to be done? So it's a really nice question.
A kind of extension, I think, to this thought process, and this might just be a bit of an overcomplication. I see how in the specific briefing that we've got, this delegation fulfills the need, but it's quite easy to imagine a slightly more complex program of which this is only one aspect. Where, for example, there might be other objects that need to interact with HR manager, or that HR manager needs to interact with. But perhaps another object that actually COO and HR manager both need to interact with. HR consultant, whatever. And how that feels like that becomes a challenge with this kind of delegation, because it's like, this is kind of like Russian dolls. And how can something that's inside one doll interact with something that's outside of it?
Yeah.
And I guess my question is that a different kind of exercise, and is that not something that's worth picking over too much in this example right now?
Yes, I want you to keep thinking about it, but not for this exercise.
Okay.
And when it crops up again, or when we can find an example to go through that does it, then let's tackle it then. But essentially what you're talking about is a couple of things. One is,
I guess, what if two objects need to delegate to the same object? Be an example of that.
Yeah, and really at the moment, these objects we're just passing around references and not the actual objects themselves. So you can actually still inject a reference to in multiple places. But you have to be very careful about that to make sure that your state is what you want it to be. because if you have the reference to an object that's shared in multiple places and you ask one to update it, and then the other one depends on it, then it gets a bit tricky. But you can still, for example, inject an instance of code to multiple places, and different objects can still work with it, but they all have the same reference. Mm-hmm. So there's that problem, and in order to solve that problem, we need to just create instances of what we need to do work with. So rather than keep the whole object, think about actually what is the work that needs to be done, and find a way to design it in a way that you only have an instance to do work in that one particular context. So really try and think about what is the core thing that needs to be done.
So if in your program you kind of have the need of 5 COOs to go off and do different delegated tasks, that's not a problem so long as the COO doesn't need to hold some consistent piece of information across those 5 instances.
Yeah.
Yeah, that makes sense.
That's also would probably be a design smell, is what we would call it, because there's probably a different way to design it that you shouldn't need that approach. But so yeah, when we get to it, let's when we have to encounter it, let's talk about it. But I don't want to spend more time on it right now.
Just one more question.
Yeah. Mm-hmm.
So I guess this was quite a neat example because each class was able to just have like an equal number of methods pretty much. But if we say look at like the airplane or the Boris bikes, where I guess like the bikes one had the majority of methods, and the airport had the majority of methods. Is it really, should our motto be to try and get equal number of methods in each class, or to minimize the number of methods in one class by redistributing?
Great question. It's probably not a bad thing to think about in terms of trying to have like an equal distribution to begin with. It will probably push you in the right direction. Okay. It will break at some point because you'll have some objects that have no dependencies. So, for example, the plane didn't depend on anything else. It was almost like at the end of the tree of dependencies. You had like the airport that had a dependency weather and it had plane. And so it's probably going to have more methods, going to have more things, a little bit more complexity to it. So if you think about like a tree structure, almost like an inverted tree structure, where you have at the top like a few objects that then use other objects to do work, the ones at the top are probably going to have like a bit more to them. Not always the case, but probably. So there's always going to be some kind of gradient from the top and then to the bottom, where you have like very small specific objects that do like one thing. I think so. What I'm trying to say is like I see a picture in my head of or like on a gradient of complexity, where we have more complex at the top and least complex at the bottom. And as a result, there's almost like a correlation between complexity and like number of lines and number of methods, right? So it's a good thing to think about at the moment, so you can try and redistribute and try and think about making your classes be more responsible for one thing, and that's a really good thing to always think about. Your rule of thumb is like, classes should be small in size, have as simple as methods as possible, and use other classes to do bits of work for them. But that's in like an end state. So sometimes students get quite frustrated because they want to be able to do it right now. They want to be able to design a system with 4 or 5 classes all working nicely together. And you should start with 1 or 2, and then extract behavior. So just know it's a process. You don't always go straight into knowing that you need all these objects, if that makes sense.
Yes, yeah, no, that was good. Yeah. Thanks.
Amy, or Anastasis, or Sabir, what are you thinking?
I find this quite interesting. I was just wondering about because at the moment we are doing a test-driven development, so we are writing the spec files first.
Yeah.
I'm just wondering how that's going to work, because you basically just wrote all the source code.
Yeah.
Yeah.
Yeah, one big spike. And a spike is a way to describe writing code without having tests that cover its behavior. And yeah, that's correct. So this is a demonstration just so we can not worry about the test side of things. If I had this picture in my head, I would then take it slowly and just write as I did, one class at a time. So my spec code might look a little bit like this. So I imagine it would be like a CEO. You can all see my screen still, right?
Yeah.
Yeah. Let's describe make company efficient. So here, setup is going to be create a CEO. And here I want to inject in a mock. So let's call it coup. So coup would be a test double. And it would have a method called down here, because I know it needs to respond to this method, find company savings. And return, let's just say, I did some stuff. I cooked the books. I don't really care what it does. I just want to know that the method is called, because that's all that happens in here. The only thing that happens in this method is that I ask the coup to do something. So if this gets returned, I know I've done my job properly at the moment. So I need to put this in an example. Sorry, it asks coup to do work. Let's just say that. So this is part of my setup, and then I want to execute some code. Expect CEO dot make company efficient to equal I cooked the books. That's probably how I'd go about writing a test to cover that behavior. I injected a mock, so I don't have to worry about testing coup, the chief operating officer. And then when I call making that company efficient, the only thing that happens is I ask the coup to call find company savings. So I've stubbed the method and then just asserted that I do get that back. Whatever happens from the find company savings is my return value. Does that make sense?
Yep.
Sorry, with do you know when you put the default argument of coup equals coup.new?
Yeah.
That means, so that, I guess that default argument works well in this, the test, but I guess that default argument means that you can't have, that default argument can't have it won't have an initialized variable, right, within it. In terms of it won't be able to sit that, it's not got an argument, has it, the coup.new? Whilst below in coup, we give coup.new an argument of HR manager, don't we? In the initialize.
Exactly.
Yeah.
Exactly. Yeah. So if it were not to be mock, so if I didn't pass in an object, then it defaults to this instance, which by default comes with an HR manager, which needs a set of employees.
So it's useful for mocking, but it's not useful for much else, right?
Which part?
The initial giving a default argument of coup equals coup.new.
Yeah, it does both. So sometimes you want to be able to inject maybe different kinds of objects. So maybe you have a different kind of chief operating officer, or you have a different kind of object. So it allows you a little bit of flexibility at runtime to say, maybe I want a different object to be passed in.
Okay.
So it does help you a little bit. and it means you don't have to always constantly set up a lot of your objects at runtime. It just happens by default.
Okay, but I thought we couldn't make a new, like if I tried to do q equals q.new with no arguments, it wouldn't be happy because it expects the one argument. Oh, because you've given it default at there. Okay, I understand now. Okay, yeah.
You should be able to have a look at. I deleted it and then did it again, but this file in the GitHub repository should have something similar to this. I might have done a slightly different implementation because I can't remember what it was meant to be. But you should be able to have another look at it in the GitHub repository, or if you pulled it down. But yeah, I would follow this approach all the way through with just replacing the injected dependency with a mock and getting practice at it.
And the mock be set up to take take arguments. Obviously, it's not going to do anything with them because it's a mock. But let's say when you call find company savings, you actually want to define how much savings need to be made.
Yeah. Really good question. So at the moment, we're not making expectations on the arguments themselves, just on the method, on the message call. So I could pass like arguments here, and my stub wouldn't care about them. Different testing frameworks will then have more support for making assertions on specifically the arguments as well. But I don't want to worry about that because that's not important at the moment.
So it would, sorry, this test framework, if on line 31 you now added in a like brackets 1000 or something,
it would still, the mock would still work. Yeah, the stub would still work. And I added support for that.
Okay.
Can you add a mock inside the mock? Like in place where when I cook the books to insert another mock that will do something else?
Yeah, so great question. So frequently,
the second stage, let's say.
Yeah, so you can return anything you want. So you could return another mock if you wanted to. So maybe we could do like.
Is a second mock needs to be created outside?
Like here, so I could create another mock here.
Okay.
And just return it. And this would be what happens if you want to like pass in class objects. That then in a method call new on a class, you use the same approach. So you would just, for example, say this was like the coup class itself that we're trying to mock. We just say when we call new on it, we'll get another mock, and that would be something like a pattern that you could follow, which would allow you to mock classes themselves.
So you do a mock called like coup class, which had a stub for new, and returns a mock called like coup instance, which has a stub called whatever it was called.
Find company savings. Yeah.
Cool.
Yeah. So we'll have more practice on this on Sunday, on this part of it. So I don't want you to worry too much about the testing or stubs of this. This is not what is too important about it at the moment. What I want you to get practice at is just using classes and forwarding messages to them.
So my question is like, when you return, like instead of another mock, can you inside there allow another mock to receive another argument and return something else?
I'm not sure I know what you mean. Can you paraphrase it?
Like, okay, we allow the test double to receive the find company saving, right? And to return back that I cook the books, like a string. On where it returns I cook the books, can we like inside there allow another mock to receive something else?
the code would still evaluate, and the return value would be whatever happens as a result of the to method here. So like grammatically or language-wise, it would work. But my question to you would be, what are you trying to do? Why are you trying to do that? Because you can just have another line here above or below that allows your mock to do something else as well. The purpose of having a return value is when you call find company savings, you return a value. So for me, that's like trying to give behavior to an object. I'm trying to say my coup here, or this object is going to have a method and return a value, which is a different part of the test setup to stubbing behavior.
Anastasis, are you thinking about sort of trying to extend the test to be testing sort of further down the tree of the source code? So I think the idea here is that what you want to test that CEO does is just that CEO does the specific thing that CEO needs to do, which is call COO. And then separately you write a test to make sure COO does the three things that COO is supposed to do. And if one of those calls HR manager, you don't test that as part of testing COO. You write tests for HR manager and make sure HR manager does what it's supposed to do. Does that help?
Yeah, this is just a unit test for CEO. I'm not testing anything else at the moment. I will write another test for this class. Yeah?
Yeah.
Cool. Sabia, what are your thoughts?
To be honest, I feel like I need to refresh my knowledge of injecting dependencies. So I need to go back a few steps. But I did observe that the domain model that you created on the Miro board was quite different to what we've been doing so far. So for example, we've been looking at objects and methods quite like in a linear fashion, but this is obviously stringing on different objects and methods as well. So yeah, that was quite interesting.
Is it useful? What are your thoughts about it when you see it done this way?
Yeah, I liked the visual as well. So that did, that does make sense. Which it might not be easy to see in the code, but visually it is.
One of the reasons I did that is because for me, this is already the objects and messages at the top on the company structure. So I use my objects and messages that this has. Object CEO has executes a method, make company efficient. All that work had already been done, essentially. And so then I use that to draw a picture of how the objects are going to relate together and work together. And so this is actually one of my, I use the two together. I start here making sure I have like a set of objects, sort of like methods that are going to work. And then I try and diagram how they're going to send messages to each other. And sometimes I can do that in a table in README, but I prefer to draw it out. But different people work in different ways. So find a way, once you've got your list of objects and messages, how are you going to just draw out how they're going to work with each other? I like drawing boxes and arrows. It's quite a common tool to use. But yeah, definitely use this as a way to sort of explore and see like how you can do something similar when you have multiple classes working together. I find it's nice to sort of share with people when we're working together in just like a line, and we can both draw on it and like cross things out and erase each other's work, and it can be quite fun.
Do you use flow diagrams as well?
Yeah, exactly. Personally, I want is like rough and ready tool to use. I hate having to spend too much time trying to like get all things in right order. But some people love that, and they like that order. And so just use a tool that makes sense to you and gives you value. One of the common complaints that I have is that, or is made of me, is that sometimes my handwriting can be quite messy. so it's definitely what you feel is useful.
If you like flowcharts, there is a nice free tool called draw.io that can save to your Google Drive. I'm sure it will save elsewhere as well. But
I know we use Lucidchart, but I don't know if you have to pay for that. I'm not sure.
Draw.io is definitely free and quite quick to pick up and get playing with if flowcharts are your thing.
I don't know if it's my thing yet. I need to just cover that, I guess.
Yeah, I will. Cool. Okay, so